In this video, we will learn how to take an integral of a product of a trig function and an exponential function. So we have this e to the x multiplying this cosine of 3x here. So first, let's take a look at what happens if we try u sub on this. So if I try u sub and I let u be equal to e to the x, du would be, its derivative would be e to the x, and then we'd write that dx next to it. But if I look at the u and the du, nowhere in either of them do I see a cosine of 3x showing up. So that makes me pessimistic about whether this is going to make that cosine term cancel away. So this is probably not going to be helpful. So I'll put a slash through this. The other natural choice for what to try for u might be the other term, that cosine 3x. Then du involves chain rule. The derivative of cosine is negative sine, so negative sine 3x, multiplied by the derivative of the inside, which is 3. And then I write the dx at the end. And again, if I look at the u and the du here, in neither one of them do I see an e to the x showing up. So that makes it unlikely that when I follow through with this, we'll be able to cancel away that e to the x. Okay, this is probably not going to work. So u sub doesn't seem to be helpful. What if we try integration by parts? The other indicator that that might be useful is we have a product of functions. We don't always use integration by parts when we have a product, but often it can be helpful, especially if one of our other methods doesn't work. So let's set up our parts, u and dv. And we could actually do this either way. So let me just make u be the trig part, cosine 3x, and dv be the other stuff, e to the x dx. Okay, usually you want to pick u to be something where its derivative is simpler than it. But in this case, I don't think that with either choice of these, the derivative will be all that much simpler than what we start with. So each choice I think is okay for u. All right, and then I need du and v. So the derivative of cosine 3x, we just did that up here. That is negative sine 3x times 3 and then dx. The antiderivative of e to the x is e to the x. Putting this in a thought bubble, let's use this. So I get u times v, so cosine of 3x times e to the x minus the integral of v du. Okay, so for v du, let me give myself more room. V is e to the x. And then this minus 3 that shows up in the du, let me pull that out in front of the integral because it's a constant multiplying the function. And that still leaves me with sine of 3x dx in the integral. Then this double negative becomes a positive, so plus 3. Now if I compare my integral to what we started with, it looks kind of similar. Like I still have an e to the x, I still have a trig function, it's just a different trig function. So it didn't seem to have made much of a help to me, at least at first glance. But let's persevere with this. Let's try integration by parts one more time. That did something for us first. Let's try it one more time. Integration by parts again. So let's do it one more time. And let's set up the parts in the same sort of way. So let's let u be the trig stuff, the sine of 3x. And I'll let dv be the other stuff, so e to the x dx. And then I'll get my du and get v. So v is just e to the x. And then du, I'll need chain rule for this. Derivative of sine is cosine. And then the derivative of the inside is 3. So multiply by 3, and then dx. All right, so putting these parts in a thought bubble, if I use them for this integral that I now have, we end up getting, so in front we have cosine of 3x, e to the x, and then plus 3. And I'm going to put a big old bracket now for what the integral gets replaced by when I do integration by parts. So we get uv sine of 3x times e to the x minus the integral of v du. So v du gives me e to the x times 3 cosine 3x dx, and close the bracket. Okay, so let's compare this integral that we have to the one that we started with. And one of the things that you might notice is, wait, except for this extra 3 popping out here, we actually ended up with the exact same integral that we started with. So this seems like it did nothing for us. It seems like it kind of took us back to where we started. But there's a little trick that we can do with some algebra to get to our answer. Okay, so how does that work? We have this 3 in front of the whole bracket. I'm going to take that and let's distribute it to this first term and to that second term, that integral. So doing that, it gives us in front cosine of 3x e to the x. We distribute the 3 to get plus 3 sine of 3x e to the x. And distributing to the integral, we'll get a minus 9 pulled in front times the integral of e to the x cosine of 3x dx. Okay, so we have this. All right, so what I'm going to do now with this is let's think about what we have. We started off with this integral here. I'm gonna write this on, running out of room. I'm gonna write it on the next page. So I started off with the integral of e to the x times cosine of 3x dx. And we got that it equals this whole thing over here. So I'm gonna copy this. I am gonna copy this. We got that it equals this whole thing over here. Okay, and now I'm seeing the same integral on both sides. So I am seeing this integral appear on both sides. So I'm going to introduce a new variable for that. I'm going to call that whole integral just I, capital I. All right, so if we do that, on the left-hand side, we got I. On the right-hand side, this equals cosine of 3x times e to the x plus 3 sine of 3x times e to the x, and then minus 9 times I. So my goal is to figure out what I is. So I'm seeing I show up here and here. Let's just get all the i's on one side. So if I add 9i to the left, we are going to get 10i equals these other terms, cosine of 3x times e to the x plus 3 sine of 3x times e to the x. And now I'm one step away from getting I. I just divide by 10. So dividing by 10, we get that I, the thing we wanted is cosine of 3x times e to the x plus 3 sine of 3x times e to the x. That whole thing getting divided by 10. And the last step is, well, we started with an indefinite integral. So at the end, I need to remember, okay, I need that plus c. I need to write my plus c. Okay, and we got it. So that is how we can use a bit of algebra, this trick here, to work out the integral where I have a product of an exponential function and a trig thing. This works if I have a cosine or a sine with it. One of the key things that we need to do to make this work is when we do this integration by parts twice, it works as long as we stay consistent. So if I picked u to be the trig thing here, in the second time, I have to pick the trig thing again. If we had picked the exponential thing to be the u, then even in the second time, I'd have to pick the exponential thing to be the u. As long as I stay consistent, it's going to work out.